Hey everyone, it's Miss Lloyd, and today we are looking at functions. We've got domain and range. So domain pertains to our x values of our function, and range are our y values of our function. So these are the places where the function is true. So here we have just a list of numbers of ordered pairs, and so all of our x values pertain to our domain, and our y values are the ranges. And so when it comes to mapping, we just make a list of all of our x's and then a list of our y's. So now I've got my list, and I'm just going to go through each of my points and map those points. So I have 0, 4, 1, 3, 3, 5, and so on. And because I have multiple x values going to the same y values, some of the same y values, I have some of these y values repeating. This isn't a function of x because we have way too many y values. Not each of the x's go to its own y value. Of course, that's not what it's asking, but just, some information. So again, here, when we're finding the domain of each function, we're just listing out the x values. And I always have students who are asking, like, oh, Miss, can't we just say -2 to negative, or to +2 and just have like the x in between, some inequalities? We can't really do that because we don't know if 1.5 is in our domain. We only know these solid counting numbers. So because we don't have that, we can only assume what they've given us. Our next bit, this isn't necessarily what the x's can be, but because we have in the bottom a variable, it's more of what we can't have. And so I've said before in some of my other videos, and definitely to my students, that we're not allowed to divide by 0. So this denominator, the 3 minus x, it's not allowed to be 0. So I set this not equal to 0, and then I solve for my x. So I know here that my x cannot equal 3, so my domain is basically all of the numbers that are possible except for 3. 3 is the only thing I can't plug in, because if I plug it in, then I'm dividing by 0, and then the world explodes, and there's no more tacos. It's a really sad day. Circumference of a circle, this isn't necessarily like what we can or cannot have. I mean, ish. Whenever it comes to circumference, we're talking about a measurement, and we can't have negative measurements. So whenever I'm worried about circumference of a circle, I'm paying attention first off to my r. This is going to be my domain in this case. And I know that I can't have negative values, so r has to be greater than or equal to 0. And then this one over here, a rule that we have when it comes to square roots is that we don't take the square roots of negatives, or it ends up not being a real solution. We end up with imaginaries. So we don't want to have imaginaries. So the stuff underneath has to be positive, or it can be 0. We can take the square root of 0, that's 0. So then I'm going to set this greater than or equal to 0. So that number can be 0, it can be larger than 0, it just can't be smaller, aka negative. And I solve for x. We do have to be careful when we're dividing by a negative number. That means that we have to flip the inequality sign. So I end up with x is less than or equal to 4/3. So anything that's smaller than 4/3, I cannot plug in, otherwise I end up with imaginaries. When it comes to representing functions, there are a few ways we can do that. We can either write it out in a sentence, so with like actual words, which is not my favorite. I'm not the biggest fan of words. I always spell them wrong. The next one is numerically, so we can have a table or a list. You can see below, there's an example of a table. We can do it graphically, so we can have a coordinate plane and have those points on a coordinate plane, or even a shape drawn in. Or we could have it algebraically, so we have it as an equation. Those are the 4 ways that we can represent functions. When we're testing functions, today we're going to be focused mostly on each input has exactly one output. So for every x I put in, there's only one y value that it would go to. So if we have multiple x values going into the same y value, then we may have some issues. Or multiple y values coming out of the same x value, we may have some issues. So my favorite thing to do is a vertical line test. I'm a very visual person, so I like to graph it and then see how it looks from there. So then here we want to tell whether the relation represents a function. So I'm looking through my x values first. So each of these x values, I have one y value that is repeating, which is totally fine. It's the x values that can't repeat for the same y. So here, because we're looking at if the relation represents a y as a function of x, because we don't have any of our x values repeating, those are all individual, and we have the y values that go to those, we're totally fine. So this is a function. The next thing I'm looking at is an equation, and this is actually the equation of a circle. And so I know a circle is going to look like this. There, now it's nice and pretty and perfect. So on things like this, I like to do the vertical line test. So the vertical line test is basically saying if I have a vertical line, so here's my line, if I go anywhere on that graph and I hit the graph more than once, then it's not going to be a function. That means that I have an x value where it has the different y values. So here, I've got an example of it's hitting twice. So because this hits twice, we fail the vertical line test. So then here we want to let f of x be a function and, well, not necessarily a function, that is function notation though. In this case, it is a function. And we want to find each function value. So basically what they want us to do is take this 2 and plug it where the x was in the original equation. So whenever we have f of 2, they want us to plug that 2 in for x. And I just solve from here. So my final solution, I want to have f of 2 is equal to the negative 2. We could also say that this is 2 comma negative 2. F of x is representative of a y. So either of these are perfectly fine solutions. We do want to have that official notation f of 2 because it's saying that I plugged in 2 in order to get the negative 2. So next thing we're going to take a look at is a piecewise function. So when a function is defined by 2 or more equations. So basically here, I have 2 scenarios for this function. So when x is less than 0, I'm going to use the top. And when x is greater than or equal to 0, I'm going to use the equation on the bottom. So it's just defined by 2 different equations. It decided to do one thing and then changed its mind during its midlife crisis and decided to do something else. At least that's how I like to think of it. It's like someone's midlife crisis. They start following one path and they realize, hey, you know what, that path really isn't for me. And then they kind of just turn around and do something completely different. So negative 2 is less than 0, so I'm going to be plugging it into that top equation. So when I plug in negative 2, I end up with 5. The second one is a positive 2, and so positive 2 is greater than or equal to 0, so that means I'm going to use the second equation. And the last one I'm going to save for my kiddos. So when we're finding values for which f of x is equal to g of x, we're basically just setting the two equations equal to each other and then solving for x. So for this situation, we want to find all the values of x for which these two would be equal. So basically where they're exactly the same or where they're crossing each other. So then when we're doing this, I've got to have my colors. We've got our first equation and we're going to just set it equal to the second. Combine some like terms and get our variables alone. So this, it looks like I may have to solve for 0, so I'm going to move everything over to the other side. I like to have positive x values, so I'm going to move everything so that my x squared is positive. I also see that we have a 2 in common, so I'm going to take that out of everything. Like working with smaller numbers, just makes me feel better. Now I do have a trinomial and it is also a quadratic, so I'm going to use my M&A method in order to factor it. So I'm looking for numbers that multiply to give me negative 12 and add to give me positive 1. And that would be positive 4 and negative 3. So x plus 4 and x minus 3 are my factors. So I set each of those equal to 0. And I've got two solutions where x is negative 4 and x is positive 3. So these are the cases where we would have the same exact thing, where they're true for both of those equations. And the last thing I'm going to look at with you guys is the difference quotient. So this is something that's used with calculus. So we're just going to touch on the algebra part of it and what it looks like when it's solved. It's not the most satisfying of equations, if I'm being honest. So here they tell me what the f of x is, and what they want me to do is do an x plus h inside of the first x value here, and then minus just the equation itself without anything changed. So the way that first bit looks when I do f of x plus h, I'm just replacing all of my x's with x plus h. And then I'm subtracting the equation itself and dividing all of this by h. So the first thing I'm going to do is flesh out this x plus h quantity squared. So remember that's like x plus h times itself. So when I do the distribution for this, I end up with x squared plus 2xh plus h squared. So I would have had xh plus xh giving us 2xh. I can distribute in my 2. And I'm going to want to distribute that negative sign. From here, I'm going to simplify by combining any like terms that I have. So I see I have a positive 3 and a minus 3, which are just going to cancel each other out. I have a positive 2x and a minus 2x, again, cancel each other out. X squared and negative x squared, canceled out. So it looks like I'm just left with my h squared plus 2xh plus 2h. It's a lot of h's. Actually, they have an h in common, so I could take an h out of the top, making it h plus 2x plus 2 on the inside, and cancel all that out with the h on the bottom. So my final solution here is just the h plus 2x plus 2. Nothing more I can do with that. And that's all that I have for you guys today. If you found this helpful, please like and subscribe. If you think this would be helpful for someone else, then please feel free to share. Spread the love.